Hi guys, this is Richard from robotics background. Today we are gonna see about an autonomous mobile robot doing autonomous navigation using Isaac Sim. Okay, you all will know about Isaac Sim. What is mean by Isaac Sim? Yeah, Isaac Sim is an application which is built on NVIDIA Omniverse that enables developers to simulate and test AI-driven robotics solutions in physically based virtual environments. Okay, let's dive into the topic. Right now I'm gonna launch Isaac Sim. I'm launching the ROS2 humble version. It's been starting up. Yeah, it will take some time. Yeah, we get an Isaac Sim new stage. It is empty. So right now in this we are gonna create an first thing. We need some environments to do our robot and autonomous. So for that in Isaac Sim there are so many environments are there. So for that I am taking simple room. So for that you need to go inside create and then Isaac in that environments simple room. It will take some time. Yeah, I've been using simple room. See, this is a simple room. In this environment we are gonna create an autonomous mobile robot. Okay, for autonomous mobile robot we are gonna use an ROS2. We are gonna use ROS2. What is mean by ROS? ROS is a communication layer. You all will know about that. You all so famous in that. So in ROS we need 4 most important topics to drive a robot into an autonomous. That 4 important topics is, the first thing is odometry. The robot needs to know where it is, where am I. So for that we've been using odom topic, and then TF trees to give the position and orientation with respect to the map, and then we need a command velocity to drive the robot, and then the 4th topic is scan topic. So through that scan topic the robots gets know the information about the environment. Okay, so for this, and also for the scan topic, here we've been using a lidar in a simulation environment. Okay, in an empty environment I'm gonna import my robot. So and basically ROS or ROS1 or ROS2, how do we import any robots? Like normally we would design any robot in a Fusion 360 or SolidWorks, then we would convert that model into an URDF using URDF exporter plugins. So that's only right. So here also the same thing, but here I'm gonna use the TurtleBot 3's URDF. Okay, I'm gonna import it by I click Isaac Utils, then workflows, then URDF importer. So in that you must need to see this fixed base link. In our mobile robot the fixed base link is not gonna to be a fix. So I'm deselecting that. Then we are gonna control the robot through velocity, not by position. The position would be useful for the robot arms, for industrial arms. So here I'm changing that to velocity. So thereafter I need to import, I need to give my URDF's file location. So where I kept that, say inside turtle, under description URDF. So here I've been TurtleBot 3 burger.urdf. I've been taking this URDF, then select URDF, then I'm clicking yes. Okay, that's all. See, our robot is been inside this. This is our robot inside an environment. So first we need to check that is the gravity is been enabled or not. So for that, see, right now I kept the robot not in the ground, it's been in upside. So if I click the play simulation button, it's been dropping down. So it means gravitational physics force has been working inside the Isaac Sim. So right now we can start to script this to convert this mobile robot into an autonomous. So for that, in Isaac Sim we have an facility for visual scripting. So for that we are using action graph, which is an omnigraph node graph. So right now we are going to start to create an visual scripting. So for this I'm gonna take on playback ticks. From this only the ticks calculations, not that encoder ticks, not that like kind of things. It's the similarly like an clock. It should generate an ticks. So by that the environment gets to know the robot is being started. Okay. So then what are the important topics we need? Right now our first goal is to teleoperate this robot. So for that, Isaac read simulation time we need, and then scale we need, Isaac ROS2, yeah, ROS2 context to define the domain IDs, and then publish subscribe twist to subscribe to the command velocity which is been published by teleop twist keyboard. The teleop twist keyboard will publish the velocities in command velocity topic. So we need to subscribe to the topic. So here I've been using ROS2 subscribe twist. So we need to give this to one controller to drive our robot. So for that I'm using articulation controller, using differential drive controller, and then enter math to separate the angular velocity and linear velocity. Break 3 vectors, 2 vectors we need to x and y, x, y, and then we need make array, so and also we need to give an constant token like to define the joints. So for that where constants, define constant tokens. Okay, constant tokens, 2 tokens we need. So constant tokens. Okay, I think it's been over. So we can right now we can start to give an connection. Okay, and text to exec in to start this subscribe this node, and then we also from this we can give an exec into differential controller. So from linear velocity we need to convert it into an stage form to scale it up. So here I've been linear velocity, then from this result to vector, and then from this x it is linear velocity. I'm giving this to decide linear velocity, and then for angular velocity I'm giving this to vector, and then from this z which is giving to decide angular velocity. Okay, and then we must need to check it out that ROS2 subscribe twist will need to subscribe to the command velocity topic. Okay, command vel. Okay, then we also need to give connection to articulation controller, velocity commands to velocity command, and then we also need to give that exec in to start this articulation controller. So for that we need to bring these sticks to articulation controller, and then after we need to give the joints. So joint names we need to give for the robot to drive. So here TurtleBot 3 burger, under base link you can see the joint, wheel left joint, wheel right joint. For left wheel left joint. So at here the value we need to mention wheel left joint. Okay, wheel left joint, I given that wheel left joint, and for right side I am going now to give wheel right joint, wheel left joint and wheel right joint. So after converting this into as an array I can directly give into an joint names. So here the input is 0, so I need to, so input 0 and input 1 I got it. So from this 1 to 0, and then from here to input 1. Okay, then after it's converted into as an array I can give this to the joint names. Okay, right now we've been given the joint names, exec in, and then the velocity commands. Okay, what's the next thing? Simulation time, is there any timestamp is there? So no timestamp is there, so we can delete it, no need of that, but we need to give the context. So at which domain ID it is gonna to be run. So under domain ID 0 as a default we are gonna to run this, so I'm giving that to there. Okay, everything we've been set it out. Okay, command velocity, differential controller is been there, velocity command. At articulation controller we need to give the articulation route, which is our articulation route. To check it out, the articulation route, we must need to check that by clicking this filter and then physics articulation route. Right now I am gonna take the base link, so but here the base footprint only is been available. So to enable base link as the articulation route, so for that I can right click this base link, then add physics articulation route. So now you can able to see under the property, see articulation route is been enabled, and then what is self collision enabled. If you are gonna to use an robotic arm, in robotic arm the robot arm should not get collide with itself on its own body, so that's this self collision enabled. But mobile robot we doesn't even need that, so no problem. Okay, oops. Okay, articulation controller we've been set it out, property under target prim. Right now we can able to give base link. I'm giving that articulation controller and articulation route base link, okay, which is the articulation route. And then in differential controller we must need to get know the wheel distance, wheel radius, and then how much maximum acceleration the robot needs to move. So I doesn't know how much it will move, so I'm searching that TurtleBot 3. Okay, TurtleBot 3 drive Isaac Sim. In the Isaac Sim documentation itself they have been mentioned the how much maximum acceleration, everything they have been given. Max linear speed is equal to 0.22, wheel distance is equal to 0.16 meters. This all been in the meters, so I can able to give maximum linear speed 0.22. Maximum linear speed I've been set it out to 0.22, and then wheel distance which is 0.16, and then wheel radius which is been 0.025 meters. Yeah, I've been set it out. Right now the robot is been ready through visual scripting using action graph. We've been given the connections, so this is the action graph, final action graph. Okay, we can able to see. Okay, right now we can able to check it out that. So we can able to okay, right now we can, I've been saving this under and downloads a new version 1 for YouTube. I've been using YouTube. I've been saving this even youtube.usd. Okay, I've been saving this, and then I click play simulation. I've been clicked the play simulation, and the play simulation. Okay, I've been running the teleup twist keyboard. In the teleup twist keyboard, right now we can able to check it out. It is the robot is moving or not. See, our robot is moving. It's moving forward, down, and then it's been rotating left, right. Yeah, that's it up. Right now our robot has been working. That's all. Okay. Right now we've been set it out for the command velocity. You can also check that too. ROS2 topic list. See, we can able to see the command velocity. Then we need another 3 important topics: odometry, and then TF, and then odometry, TF and then scan topic. Okay, right now we are going to get another 3 topics, so I am just saving this action graph for differential drive control or something else we can. Okay, I am giving the namespace action graph for differential, action graph differential. Okay, I am gonna create another graph for computing odometry and to publish TF tree. So the same things, we need the basics like on playback tick we need, and then under compute odometry node to compute the odometry, Isaac read simulation time. If there is any timestamp, we need to give that, and then we need to publish clock. That would comes under Isaac LiDAR. Okay, next we will see. Right now we are gonna concentrate on odometry and TF. On Isaac ROS2 Isaac read simulation time, then ROS2 publish clock. This clock topic will be subscribed by RWizard to get synchronized with Isaac Sim and ROS time. Okay, ROS2 publish odometry. We need odometry, and then we need raw transform tree and publish transform tree. Okay, we can start to give connection. Okay, ticks with execin. So we need to give execin. Okay, I forgot to stop this. Okay, I stop it. After giving connection, we can start to use it out. Okay, Isaac compute odometry node, and then for ROS2 publish odometry, and then ROS2 context node to context. So for this also we need to give execin from ticks, and then we need to give the context. Okay, context. Then where is that? Okay, is there any timestamp is there? Yeah, timestamp is there. Here also timestamp. So we are gonna give the simulation time timestamp. Oh yeah, we've been given that. Here also timestamp is there. So we are giving timestamp per connection. Timestamp. We've been given timestamp. Okay, right now the basic connections have been done. So hereafter we need to quality of service profile they are being asking. So we need to have ROS2 quality service profile node. Okay, after importing this quality service profile node, at basic as a default, it's been in the durability with volatile and history with keep last and reliability with reliable. Okay, from this quality of profile we can able to give it to the publish clock, and then wherever it is mean quality of service profile with quality of service profile, and then quality of service profile, this with quality of service profile. Okay, I've been given the quality of service profile, and then here also I've been connected. So right now we for compute odometry node we need to give the chassis prim. So here the chassis prim is base link, so I've been given as a base link as the chassis frame. Okay, next to publish, under which topic it should need to publish. So under odom topic, the odom topic data should need to be published. Okay, I'm giving the odom frame ID as odom and then chassis frame ID as base link. Okay, right now for the publish raw transform tree, for autonomous mobile robot navigation, the nav2 stack would ask you the structured TF tree like map to odom. The map to odom TF would be published by AMCL. Then ODOM to base link would be published from this raw transform tree, and then base link to laser from our robot. ROS2 published raw transform tree has been set to parent frame ODOM to base link. Then this published transform, which is the parent. Here the articulation route is been set for base link, so I am giving the base link. So from after that I can start to give caster bank link, and then IMU link, and then base scan for laser, and then wheel left link, and then wheel right link. That's all. This is our TF tree for our robot. According to the position and orientation from the URDF, it will start to publish the TFs. Okay. Yeah, we all set it up. Quality ROS2 publish transform tree has been set it up. Publish transform tree has been also there. Under base link, publish odometry, everything has been set it up. Okay, we can start this. Mission time. Okay, this is our final tree, so we can start to run this and check it out. Is it publishing odometry and the TF? I've been playing this. Okay, I can check it out which are the topics which has been available right now. See, we can able to see the ODOM topics and the TF topics. Okay, we can check the TF first by using RQT. Under RQT you can able to see this. ODOM to base link is been there, base link to base scan is there, left link, right link, IMU link, caster back link. Okay, we all got it up. This is the TF tree which we got from URDF, from the position orientation according to URDF. Okay, right now we need to check it out. Is the data is publishing in ODOM, ROS2 topic echo / ODOM. See the data till right now it is been in 0. Okay, we can able to see the data is been 0. Right now I am going to teleoperate it and checking that is the data has been publishing or not. See, I am making it slow, and then I'm moving the robot to reverse. See the data. Okay, the TF is been static. Why? Okay, we made one mistake. That mistake is for the raw transform tree from the ODOM, we doesn't give the position and orientation. Position, orientation, anything we doesn't give any connection. That's why there doesn't publish any velocities data. So I've been set it out angular velocity, linear velocity. Okay, I've been set it out linear velocity, angular velocity, and then orientation, and then the position, orientation, linear velocity. Okay, angular velocity I've been set it out. Okay, everything we've been set it out. Okay, right now we also need to, for raw transform tree, to if we lift like this, then the TF will be like static. Okay, then there would be no change in the ODOM TF, but we need to update the data from ODOM. So for that I am giving the connection for this two, from position to translation, and then from orientation to rotation. Okay, position to translation, and then from orientation to rotation. Okay, this is our final action graph. So right now we can check it out. Is the ODOM has been publishing or not? Okay, ROS2 topic echo ODOM, and then teleop twist keyboard. I'm moving the robot to forward, and right now we can check it out. Is there any update? See the data has been updating. I've been stopped it. See, it's been changing. Also stopping this. Okay, ROS2 topic list. See, we can also check odometer has been there, command velocity has been there, clock topic is been also publishing to synchronize the ROS time, and then TF also we get. And final, the most important topic, we need to get the scan topic. So we need to create another action graph to publish the LiDAR data in a simulation environment. So I need to add another action graph. For that I am giving name it as action graph odom TF. Okay, then new action graph for LiDAR, the same thing, on playback tick, and then from here read simulation time, then from ROS to range sensor. To read the LiDAR beams, I am here using Isaac read LiDAR beams node. Then I need ROS2 context, so I have been using ROS2 context, and then ROS2 publish laser scan. Okay, these are the most important nodes for to publish the LiDAR data. Okay, I think that's all. Okay, we can start to given connection. So I start to give ticks to execin, and then execin ROS2 publish laser, and then we need to give timestamp simulation timestamp. Okay, there I need to give context. Okay, first I need to give the LiDAR prim, which is the LiDAR prim here. So for that I am going to, under base scan, I'm gonna to add the LiDAR prim. So create Isaac sensors. Under sensor we can see physics LiDAR, RTX LiDAR. In physics LiDAR I'm gonna use rotating. Okay, it doesn't get. Wait, let me give you another 1 minute. Isaac sensors, physics LiDAR, and rotating. Okay, by clicking this create Isaac and then sensors, after in that physics LiDAR, then rotating. When I click that, the LiDAR component is came here. So I am gonna keep this LiDAR inside and base scan. LiDAR to base scan. So the base scan frame is been added with the LiDAR. So after this I am gonna give the LiDAR prim at here. LiDAR prim under base scan LiDAR. Okay, the basically here before I tried that we need to invert this one. Invert this base scan LiDAR, rotate to -180, because at default the LiDAR is been changed to the front of the LiDAR should be this direction, but as the default it is been changed to that direction. So I've been changed to x-axis in the front of that vehicle. So for that I given -180. So right now it's been changed. So the LiDAR prim is been also given LiDAR, and then which topic it needs to publish. Under scan topic it needs to publish, and then we need to change the frame ID. The frame ID here is been base scan. From the TF we can able to see that frame ID is base scan. So I'm given here base scan, and then the topic, the data should need to be published is under scan. Okay, right now we can start to check it out, but before that I need to give one connection to this. then rotation rate to rotation rate, and then that's all. I have been connected everything except quality of service profile, so I need to add quality of service profile here. So I'm in adding quality of service profile to here, and then right now it's been in default, so been with this itself I'm been adding quality of service profile. That's all. It's been set it up. We can check is the LiDAR would work or not, and also if we need the laser scan should need to visible, we need to check it this draw lines, then only the LiDAR the LiDAR scan will be visible to our eyes. See, you can able to visible this, so we've been got that scan. We can check it out. Is that ROS2 topic list? See, we can able to see that scan topic is been there. So ROS2 topic echo / scan. See, the scan is been publishing. So right now we can the first step for autonomous navigation, we need a map. So for that we need to do a mapping. So in general ROS1 and ROS2, if we need to do a map, so we need to use some libraries like SLAM toolbox or cartographer. If it takes for ROS1, then we need to do hector mapping, G mapping, etc. So but in Isaac Sim we doesn't need that much step. Here they've been given a simple UI based mapping technique. So go to Isaac utils, then click occupancy map. Okay, then you can get here an occupancy map. So at here you need to mention, okay, under a single prim I have been putting this. Okay, in this I need to give the boundaries, which is the boundary for this map. So I am giving bound selection. After selecting simple room, I am giving bound selection. So the grid is been made, the occupancy grid is been made for our simple room environment. So at here you can able to see one change we need to do. That thing is, you can able to see that the grid is been for the height of this, but we need the map from the robot LiDAR prim. So for that I am been changing the Z value to the robot's height minus 0.55. That's the robot's height. So I've been changed that to minus 0.55. Then here it's been came. So right now I've been bound selection. Okay, sorry. Bound selection. Okay, then center selection. I've been centered it out, and then I set at the Z, and then calculate, and then visualize image. See, we can able to see. We can able to see our map. So to get it as an .yaml parameters, so we need to change ROS occupancy map parameters. Then we can able to get that .yaml parameters, and then also we can have the map. So at here I already mapped that, and the turtle I've been kept it inside the navigation stack. Now to map. So here I've been mapped that same environment using that same method. I've been saved that image, and then also I copied and pasted it as a simple room.yaml. Okay, like this you also have to copy that and then save this image, and then copy and create one new file as an .yaml, and then keep that parameters inside that, and then save it. Through this we can able to map easily in Isaac Sim. We don't need any libraries or nothing. So we can check it. Okay, right now we have map, and the most important 4 topics also we have been have. So we can right now we can able to do autonomous navigation. I'm clicking play simulation. Then right now we can checking ROS2 topic list. Everything is been there, and also map is been kept inside the turtle. So I've been going inside the turtle, which I've been git cloned from the official TurtleBot website GitHub. Source install setup.bash. I'm sourcing it, and then ROS2 launch. TurtleBot 3 navigation to launch.py use sim time is equal to false. Use sim time is equal to false. Okay, I didn't mention that which robot I have been used here. So TurtleBot 3 burger is equal to burger. Right now I can check it out. Is there any issues or error is coming? So I got it and local cost map, global cost map, and then the laser scan has been also publishing here. So everything I got it here. So right now I need to give the initial pose. I need to give the initial pose where the robot is being laid. I've been seeing the robot is okay under this big space. It's been here and teleoperate it to get localized by itself. I've been trying it out. Teleop twist keyboard. Okay, and also we can here add an odometry to check the odometry by topic. Odometry. Okay, actually it's been in correct position, but I don't know it's been in this direction or that direction. I don't know. I can't able to see the robot. Okay, right now I'm trying to teleoperate it. Okay, it's get localized. I need to check is this correct or not. Okay, it's been okay, we got it. I can't able to move this. Yeah, here our robot is there. I manually teleoperate to check that AM cell is working or not. AM cell has been working, but without initial pose I'm starting this robot, so this alignment is been missing. But with itself I can able to check. Okay, it's been going well, correct. Okay, right now I can give goal post to check that is that thing is working or not. I'm gonna give goal post. Now to goal, I'm giving goal. See, the robot is moving. The robot has been moving. I'm giving another goal little longer. Now to goal, I've been giving here to check it out it is coming or not. It's been turning. It's been coming. The robot came. Okay, it's been reached. That's all I think. Okay, today's session, I hope you've been understand that. Okay, it's been moving towards the goal. Is there any errors which has been arising in the terminal? You can also check it out. Okay, filtering drop. This which sometimes it should be related to the clock synchronization. If the draw synchronization sometimes if may get failed, this would happens. The clock is not being synchronized well, but we doesn't get any another particular cautious error. Okay, I'm giving another goal to check it out. The robot is moving in simulation world. and also in RBZ by according to our goal post. At initial itself, if we give initial post, it will go well. Just git clone the TurtleBot GitHub. So by that I'm doing a navigation. I used that TurtleBot navigation stack. I just give it the required topics. So by that I've been doing an autonomous navigation. That's all. I hope you all understand. Thank you. Subscribe to our channel Nex-dynamics. Thank you. If you have any errors or issues, you can ping me up through LinkedIn, Richard Albert, and to my master Kablan KB.